DNA is like a set of instructions that tells living things how to grow, develop, and function. It's made of tiny units called nucleotides, which are like building blocks that pair up in a specific way to form a double helix that looks like a twisted ladder. DNA contains genes, which are specific sections of instructions for making proteins that are the building blocks of our bodies. In DNA, cytosine always pairs with guanine and thymine always pairs with adenine.
In RNA, cytosine always pairs with guanine and adenine always pairs with uracil.
Transcription is the process where the DNA in a cell is used to create RNA. Helicase is an enzyme that unzips DNA, opening it up so the genetic information is accessible. Then, RNA polymerase, another enzyme, reads one strand of the DNA and creates a matching RNA copy. This RNA will later be used to make proteins. So helicase opens the DNA and RNA polymerase make a copy of it into RNA during transcription.
After mRNA leaves the nucleus, the ribosome attaches to the mRNA at the start codon. tRNA molecules bring the correct amino acids to the ribosomes based on the mRNA codons. The first tRNA carrying the amino acid attaches to the start codon on the mRNA. The ribosome moves along the mRNA, reading each codon 3 at a time. Each tRNA matches its anticodon to the mRNA codon and brings the corresponding amino acid. The ribosome links the amino acids together, forming a growing protein chain. When the ribosome reaches its stop codon, it signals the end of translation. The completed protein chain is released from the ribosome and the process is finished. The ribosome links the amino acids together, forming a growing protein chain, also known as a polypeptide chain. Gel electrophoresis is a technique used to separate DNA, RNA, etc. based on their sizes by applying an electric current through a gel matrix containing small pores. The restriction enzyme HAE3 cuts DNA at specific spots and divides it up into different lengths. DNA is negatively charged.
Molecules move towards the positive electrode, with a smaller molecules traveling faster through the gel matrix. After the separation, the gel is stained with a dye and viewed under UV light to visualize the bands. The bending patterns are compared to a molecular weight marker to determine the size of the molecules.
The Health Insurance Portability and Accountability Act, also known as HIPAA, gives you the right to access your medical records and keep your information private. You can access your records and also give other people permission to see them.
Who can access your medical records and when? There are a few entities your healthcare providers, like a doctor, need to access your medical records so they can support your treatment. Insurance companies can access your medical records because they automatically pay for your treatments. Public health agencies can access your medical records in a case if you have a contagious disease. The hospital needs to report you to CDC to prevent the other people from getting sick. Law enforcement agencies can also access your records, but only if they have a warrant issued by a judge. Family, relatives, and friends can access your medical records if you give them permission. But if you are under 18 years old, your parents or guardians can also access your medical records. Our hypothesis is that the glass with Anna's fingerprint might have had a substance that affected her heart and possibly caused her to vomit. Since the blood found was the same type as her, this also supports the idea. Eric Peplin's hair was likely found because they were both at lunch together, and his fingerprint on the note doesn't necessarily mean he wrote it or drew the skull and crossbones symbol. He could have done just one of those things. We believe Anna may have consumed something that made her dizzy, which led to her falling from the chair and vomiting. The substance she drank could also have caused problems with her heart.